Assalamualaikum warahmatullahi wabarakatuh, and hi to my students. Welcome to the continuation of the previous video lecture of abstract algebra, specifically group. In the last video lecture, I mentioned there are four properties of group. The first one is closure, associative, it has identity, and if it has identity, then it should have inverse. We can check it. And for the case of abelian group, we add one more, which is commutativity. And for the previous video, I mentioned for the case of integer under addition and also subtraction. You can also test it for another kinds of binary operation. For this video lecture, I intend to focus on the case of integer modulo n. Integer modulo n, denoted by Zn, consists of an element of integer from 0 up until n minus 1. And the binary operation associated with it, it means, for example, Zn binary operation, it means the binary operation of integer modulo n. Modulo n from chapter 1. We take the first example 1. If I define Z4 under binary operation of plus, you should know by then that Z4 must consist of 0, 1, 2, 3. And in order to represent the binary operation, we usually use Cayley table. Zero, 1, 2, 3, 0, 1, 2, 3. And how you do the operation is by plus and then you modulo 4. We start with the first two elements, 0 plus 0. 0 plus 0, then you modulo 4. It will become 0 plus 0 equals to 0. Then this 0, you will do mod 4. Which is again B0. You continue with the next elements, 0 plus 1, and then 1 mod 4 is 1, 2, 3. 1, 2, 1 plus 2, 3, 3 mod 4 is 3. With the exception of the next elements, which is 1 plus 3, 4, and 4 mod 4 is 0. 2 plus 1, 3, 0. 2 plus 3 is 5, 5 mod 4 is 1. And 2. We try to do another Cayley table, this time including the binary operation of multiplication, for example. Again, the same Z4. Z4 should consist of 0, 1, 2, 3. This time we do a different operation. Under multiplication, the same principle, you 0 times 0, 0, and then you mod 4, become 0. 0 times 1 is 0, then you 0 mod 4, also 0, 0, 0 here. This becomes 0, 1, 1 times 2, 2, mod 4, 1 times 3, 3. 0, 2, 2 times 2, 4, and 4 mod 4 is 0. 2 times 3, 6, 6 mod 4 is 2. 0 here, 3, 2, 3 times 3 is 9, 9 mod 4, 3 times 2, 3 times 3, sorry, is 9, and 9 mod 4 is 1 here. This is the basic on developing the Cayley table for the case of Zn. For the next one, I will proceed with the next Zn star. For the case of Zn star, it means an integer excluding 0. You start from the first natural number, first positive integer, which is 1, 2, 3, up until n minus 1. And the binary operation of Zn star here, it means the binary operation between the integers inside Zn star, you modulo n. The same principle like the previous one, with the exception of 0 only. Now we put an example, Z4 star under binary operation of plus. It is established that the elements inside Z4 star only consist 1, 2, 3. And you do the Cayley table to represent it. 1, 2, 3, 1, 2, 3. 1 plus 1, 1, and then you mod 4, 1. 2, 1 plus 3 is 4. Sorry, this is 2. 1 plus 3 is 4, 4 mod 4 is 0. 2 plus, this is 3, 0. 6 mod 4 is 2 plus 3 is 5, 5 mod 4 is 1 here. 3 plus 1, 4 mod 4, 0. 3 plus 2, 6 mod 4, 2. 3 plus 3, 6. Sorry, this is 5, 5 mod 4 is 1. 3 plus 3 is 6, mod 4 is 2. I double check. 1 plus 1, 2, 2, 1 plus 3, 3, 4, 3, 0, 1. 3 plus 1, 4, 0. 3 plus 2, 5, 5 mod 4, 1. 3 plus 3, 6, 6 mod 4 is 2. Okay. We try to do it for the case of multiplication. Again, the same like 4 star 1, 2, 3. 1, 2, 3. 1, 2, 3. 1 times 1 is 1. 1 mod 4 is 1. 2. 1 times 3, 3. Okay. 2. 2 times 2, 4. 4 mod 4 is 0. 6 mod 4 is 2. 3, 2, 1, 3 times 3. 9, 9 mod 4 is 1. This is the basic to develop Cayley table for Z4 star. Right now we have two groups already, which is Zn and also Zn star. The continuation of this is a special unitary group defined as Un. Un means an integer greater than or equal to 1 which is relatively prime to the n, which is defined here. So we take any integer which is greater than or equal to 1. You can also define it as a positive integer there, but also relatively prime. It means all elements inside there is relatively prime with n. Relatively prime, again we recall, is when the GCD among those two integers is 1. For example, right now, it's important for you to know what is the element inside first. For U5, 1 is relatively prime with 5, because 5 is F prime, the GCD between 1 and 5 is 1. 2 also the same, 3, 4. All integers inside this U5 right now is relatively prime with 5. Same goes for 2. For example, we take U8 there. 1. 2 is not relatively prime with 8 because the GCD between 2 and 8 is 2. Therefore, 2 is not an element of U8. 3 is relatively prime. 4 is not because the GCD between 4 and 8 is 4. So we don't include it. 5, 6 and 8, the GCD is 2. We don't include it. 7 is relatively prime with 8. Why not you try to do for U4? We start small. What will be the element inside U4? 1. 2 and 4, no, because the GCD is 2. 3 is relatively prime with 4. I must also mention that relatively prime with n, of course, it must be also less than n. I forget to mention this. Again, the concept of, for example, if we mention, right now we include the binary operation. Do the U4 under multiplication. The binary operation right now is multiplication. You know that U4 consists of 1, 3, and in order to represent this relationship, 1, 3, 1, 3 under multiplication, and how to develop it? 1 times 1. Again, is 1, don't forget. This 1 later, you mod with 4. 1 mod 4 is 1. 1 times 3 is 3. 3 mod 4 is 3. This is 3. This will be different. 3 times 3 is 9. And 9 mod 4 is 1. So it will be 1 here. We already have the basics to develop the Cayley table. In the next video lecture, we will investigate whether this Zn star and Un can be defined as group or not by checking all the properties of group, and also if it is commutative as well, then we define as also satisfy the properties of abelian group. See you in the next video lecture. Goodbye.